Hello students, now today we are going to discuss classification of discrete time signal, that is your symmetric and antisymmetric signal. Symmetric we can say even and antisymmetric we can say odd signal. So in previous class we have discussed the in classification of discrete time signal like is your that is your energy signal and power signal. So energy E of a discrete time signal can be defined as E equal to limit n tends to E equal to, that is your summation n equal to minus infinite to infinite x of n square. And in case of average power, when we are going to determine the average power of a discrete time signal x of n can be defined as limit n tends to infinite 1 by 2n plus 1 summation n equal to minus n to n x of n square, where n varies from minus n to n. So how will you define whether the signal is energy or power? If the energy is finite, we can say that the signal is energy signal. If the power is finite, we can say that it is a power signal. If the energy is finite, then we can say the energy signal. If the energy is infinite and power is infinite, the signal is called the neither energy nor power signal. So this is all about your energy versus power signal. And today now we are going to discuss that is a symmetric and antisymmetric signal. Symmetric you can say that is your even, antisymmetric we can say odd signal. A discrete time signal x of n can be defined as a symmetric or even, then condition is what? X of n equal to x of minus n, and like is your cos omega n x square, these are the examples of even signal. And in case of odd or antisymmetric signal, or x of n equal to minus x of minus n, this is, or x of minus n equal to minus x of n, or x of n equal to minus x of minus n. It is symmetrical about the y axis. As far as even signal is concerned, it is symmetrical about y axis. Whatever like this, whatever value of this is exactly same as this, we can say that even signal. This is also called the even signal, and this is odd signal. Odd signal is nothing but x of n equal to minus x of minus n, like this. Whatever value of t, like x of t is nothing but whatever value of minus t, this is nothing but minus x of minus t. This equal to this, we can say that this is an odd signal. Whatever this also equal to this equal to this. So as far as continuous time signal is concerned, then we have defined as x of n equal to the discrete time signal x of n can be defined as sum of the even and odd part of the signal. So in case of x of n, we can say that is your x e of n plus x of n, or we can say x of n equal to like this, that is your x sum of the even part of the even and odd component of the signal. Or we may say that if it is an that is your what, x e of n is nothing but in case of that is your x e of n, and x o or x of n is nothing but what, that is your, that is minus x of n, minus x of minus n. X of n equal to minus x of minus n is nothing but odd signal. So this is your x of n. So I can say that x of n is this. If I will say x of minus n, simply this is your x e of in place of n you can say minus n. Similarly x o of in place of n you can put minus n, and it is nothing but what, x e of minus n is nothing but same x e of n. X o of minus n is nothing but x o of minus n is nothing but, that is your minus x of minus n. That is your minus, that is your x o of n. So x of minus n is nothing but minus n. Suppose this is your equation 1, and let this is your equation 2. If we add 2, x of n plus x of minus n, that is your x of n plus x of minus n is nothing but x of n plus x of minus n is nothing but what? If we add 2, and this will be what? This will be added here, and this is nothing but 2xc of n, and this will be can be cancel out, that is your if you add equation 1 and 2, adding equation 1 and 2, x of n plus x of minus n is nothing but 2x e of n, or x e of n is nothing but, that is your x of n plus x of minus n by 2. This is nothing but what? Even component of the signal. If x of n is given, a discrete time signal is given, you can easily calculate even part of the signal like x of n plus x of minus n by 2. Similarly, if you subtract x of n and this is your x of minus n, if you subtract 1 minus 2, if you subtract means this will be added and this will be subtracted. This term and this term can be cancelled out and you will get x 2x of n. So that's why if you subtracting equation 1, subtracting equation 2 from 1, you will get what? 2x of n is nothing but x of n minus x of minus n, or x of n is equal to x of n minus x of minus n by 2. This is very important. If x of n is given, you can easily calculate the even and odd component of the signal. If x of n is given, you can easily calculate the even part of the signal and odd component of the signal. The even component of the signal is nothing but x of n plus x of minus n by 2, and odd component of the signal is nothing but x of n minus x of minus n by 2. Next, we have to I will show you some examples how to calculate the even and odd component of the signal. If this example is given, find out the even and odd component of the signal. So this is a signal is given here. You have to calculate the even and odd component of the signal. From this figure, you have to sample it. Sample it means what? If you sample it, this is your n equal to minus 2. Clearly x of n equal to 0. This value amplitude is 0. At n equal to minus 1, clearly the amplitude is what? That is your 2. If you are joining this point and this point and this point, this line will come. First of all, you sample it. At n equal to minus 2, the value of x of n is 0. n equal to minus 1, the value is 2. n equal to 0, the x of n equal to 4. n equal to 1, the value is your what? That is your 3. n equal to 2, the x of n is your 2. n equal to 3, the x of n is 1. And n equal to 4, the x of n equal to 0. So first of all, I just make a table here. N equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. X of n. First find out the value of x of n. n equal to minus 2, the value is 0. Minus 3 also 0. Minus 3 there is no. So minus 2, the value is x of minus 2 is 0. X of minus 1, the value is what? 2. X of minus 1, that is 2. X of 0, the value is what? 4. Similarly, x of 1, the value is 3. Similarly, x of 2, the value is what? 2. And x of 3, the value is what? 1. And x of 4, the value is 0. Once you got the values at every instant of n, you can find out the value of x of n. From n, you can easily calculate the value of x of n. After getting x of n, then you will calculate x of minus n. Simply, how will you calculate x of minus n? At whatever value of n greater than equal to 0 means n equal to 1, that comes to n equal to minus 1. n equal to 1 where? 3. It becomes n equal to minus 1. Whatever the value of n equal to 2, the value of n equal to minus 2. Whatever the value of n equal to 3, the value is n equal to minus 3. Whatever the value of n equal to minus 1, that becomes to n equal to plus 1. n equal to plus 1, that is 2. Means swapping, that is whatever the samples, it is shifted toward the folding, like x of minus n, and whatever the value of x of minus n, that shifted to the x of plus n. So this is your, this comes to minus 1, this comes to minus 2, this comes to minus 3, this comes to 1, this comes to n, like this. Just swapping whatever the value of a positive values of n, whatever the value of x of n for positive value of n, shifted to x of minus n, whatever the value of x of minus n, shifted to the respective values of x of n. After getting x of n and x of minus n, simply add it. We know that x e of n is what? X of n plus x of n minus by 2. Clearly calculate this plus this by 2, 0 plus 1 by 2. 1 by 2, that is nothing but 0.5. 0 plus 2, 2 by 2, that is 1 here. 2 plus 3, 5, 5 by 2, 2.5. Similarly, 4 plus 4, 8, 8 by 2, that is 4. 3 plus 2, 5, 5 by 2, 2.5. 2 plus 0, 0 2, 2 by 2, that is 1. 1 plus 0, 1 by 2, that is your 0.5. That is your what? 0, 0, 0, 0. So from this, you can mark it here like this. Whatever this value is exactly same as this value. This and this must be same because the symmetry, the signal is even signal or symmetric signal. Whatever the value of n equal to 1, 2.5, exactly n equal to minus 1 also 2.5. Whatever the value of n equal to 2, that is your what? 1. It is n equal to minus 2 also 1. So this is a procedure how to calculate even and odd component of the signal. If you draw like this, so that is your n equal to, this is your 0, that is your 1 here, this is 2 and 3 and this is your 4. Similarly, minus 1 and this is your minus 2, minus 3 and minus 4. Okay, for n equal to minus 3, the value is 0.5. This is your 0.5 here, 0.5, and minus 2, that is 1. This is 1. And here minus 1, that is your 2.5. Minus 1, that is your 2.5 here. Similarly, 0, that is 4. 0, that is 4. 1 is nothing but, similarly 2.5. 1 is nothing but what? 2.5 here. Here also 2 is nothing but 1. 2 is nothing but what? That is your 1. 3 is nothing but 0.5. 3 is nothing but 0.5. And this is nothing but 0. So whatever this, right side exactly same to the left side. This is nothing but even component of the signal or even part of the signal. When x of n is given, so how to calculate the even component of the signal? By means of what? First of all, x of n, if n is given, you can calculate the x of n. If x of n is not given, first of all, if this type of function is given, you have to sample it at each respective values of n equal to 0, 1, 2, 3, 4. You will calculate x of 0, x of 1, x of 2, x of 3, x of 4. Then x of minus 1, minus 2, x of minus 3, minus 4, like this. After getting x of n and x of minus n, and simply add it and equal divided by 2, then find out the even component of the signal. So now next class we will calculate the odd component of the signal and we will provide the different, how to find the or identify the even and odd component of a discrete time signal x of n. Thank you.